Okay, let's talk about lesson 9.6 in the book, perfect squares and factoring, page 508. First of all, we need to recognize that when you see something like a squared plus 2ab plus b squared, it can be immediately factored as a plus b squared. And just like that also is true on the negative side. A minus b squared is this pattern, a squared minus 2ab plus b squared. And since we're factoring, you have to recognize when this situation occurs, and then you can immediately go to this one of these two factors. So one, again, take the square root of the first term and the second term, or first term and the last term, and whatever their square roots are, multiply it times 2. If the middle is that, then you can immediately go to that factoring. All right. So what are the rules of that? Simple rules. First term must be a perfect square, and the last term must be a perfect square. And then the middle term must be 2 times the square root of the first term and the square root of the second term. Okay? So let's look at that in action. Example 1a in your book. What if I have 16x squared plus 32x plus 64? Well, I recognize right away that both of those first and last terms are perfect squares. Okay? Then I say, well, what is the square root of 16x? Well, that's, or 16x squared, that's 4x. What's the square root of 64? That's 8. So what's 4x times 8 times 2? Well, 4x times 8 times 2 is 64x. Okay? And when you do that calculation out, is it equal to my 32? No, it isn't. So this is not a candidate for using the perfect square trinomial. Not a perfect square trinomial, so this can't be broken down any further. You'd have to try something else, and I can see right away you could take out a factor. You could factor something out of there. But let's go on. Let's use this one. Now let's look at 1b. This is an example of where it does work. I look to see if I have perfect squares in the front and the back, and I do. So I call them a squared and b squared. All right, they're perfect squares. So a is 3y, and b is 2. Then I look at that middle term. Is that middle term equal to 2 times the a term and the b term? Well, let's lay it out. 2 times 3y times 2 is 12y, and is it equal to 12y? Yes, it is. So this is a perfect square trinomial. And then I can just take the a and the b and square it. Notice the minus sign. Because this is minus, this is minus. If this had been plus, then this would be a plus sign. Okay, moving on. Let's look at example 2. Example 2 is 4x squared minus 36. And in this example, they're saying, hey, sometimes you have to do other than the perfect square trinomial or all the things you've learned. So we're going to go back through all of them. What does this one look like? Well, let's first factor. And I'm going to use the long method of factoring out something, a greatest common factor. I'm going to break this down to 2 times 2 times x times x. I'm going to break this guy down into 6 and 6, and then 2 times 3 times 2 times 3. Okay? So my common factor is anything that's common to both. 2 and a 2, 2 and a 2. So that leaves me on the outside common factor. I can pull a 4 out. What's left in this term is just the 2 x's, x squared, minus, and what's left over here is 3 and 3. 3 times 3 is 9. And now I look at it and I see I have the difference of squares. So I immediately can go from that to x minus 3 times x plus 3. All right, let's look at, well, let's say I had done that differently. This is a two-step approach. Let's say I had recognized right away, I'm going to do this same problem a different way. let's say I had recognized right away that it was perfect squares, and then I could have written this as 2x squared minus 6 squared. Well, if I can do that, then I can immediately go to 2x minus or plus 6 times 2x minus 6. And then I look at it and I say, well, I can still factor a 2 out of this guy. I get x plus 3. And I can factor a 2 out of the second guy. I get x minus 3. And now I have on the outside 2 times 2, so I go 4 times x plus 3 times x minus 3. And you'll notice same answer in both situations. All right, let's go on to 2b. In 2b, we have the problem 25x squared plus 5x minus 6. So we're going to try all our different things we can try. Let's look at the greatest common factor. Let's see, greatest common factor. I look through here, I get 5 times 5 times x times x. 5 times x, so 5 and x look pretty good in the first two, but 5 doesn't go in here and there's no x. So after I go through all that thinking, there is no greatest common factor. It is 1, so I can't factor anything out. So then I say, well, is this a perfect trinomial? Well, that means, is this a perfect square? Well, 25x squared. Yeah, so the first term is perfect square. I'll just write PS, perfect square. So now the last term, then the second rule of a trinomial is the last term. Negative 6 is not a perfect square. So this cannot be a perfect trinomial, so I can't use that. So now I'm going to have to use my factoring table in the form of a x squared plus bx plus c. So if I use that factoring table, a times c is 25 times negative 6. So I'm going to be looking for a negative 150. And when they add up, they have to add up to 5. Right? Okay, and since this is a negative number here, then I need to have a positive and a negative in my two numbers. And so I'm going to start with negative 1 and 150. Obviously not right. How about negative 2 and 75? 73, that's not right. Let's try negative 3 and 50. That's 47. You can see we're coming closer to 5, but we've got a ways to go yet. Let's try negative 4. Doesn't work. Negative 5. Negative 5 and 30 gives me 25. Getting closer. Let's try negative 6. Negative 6 and 25. That gives me 19. All right, that doesn't work. 7 doesn't go into 150. 8 doesn't go in. 9 doesn't go in. How about negative 10 and 15? And there it is. There's my 5. So I'm going to break this middle term into negative 10 and 15. And when I do so, I need to say 25x squared minus 10x plus 15x minus 6. Now I need to group, and I see 25 and 15, so I'm going to group those two together and then put these two together. So let's do that. 25x squared plus 15x, and I'm going to go ahead and say plus a negative 10x minus 6. All right. So when I do that, now I can group. And when I group, I want to pull a, let's say, a 5 and an x out of this guy. That leaves me with 5x and plus 3. And over here, on the second one, I'm going to pull out a negative 2. Okay, so negative 2 out of that gives me positive 5x and plus 3. So now that this and this are the same, that means I can combine that and that. So I combine them, 5x minus 2 times 5x plus 3. And that is my final factoring of this original problem. All right, let's look at example 3 now. Example 3, we've got x squared minus x plus 1/4 equals 0. So now, since it's equal to 0, we're going to try to solve this problem. So let's take a look. First thing I notice is that this is a square and this is a square. Okay, so 1/2 times 1/2 equals 1/4, and x times x equals x squared. So now the middle has to be 2 times the square root of each one of these. So the square root of x squared is x. The square root of 1/4 is 1/2. So 1/2 times x is 1/2 x times 2 is 1x. So this is a perfect square trinomial. That's what it is. So since it's that, I can immediately say, write it as x squared minus 2 times the square root of the first term, x, times the square root of the second term, 1/2, plus 1/4. Okay? And actually I could write this as 1/2 squared. 1/2 squared. Okay? Now, when I have that, I know what my terms are. Everything works out perfectly. I can immediately go to x plus or minus 1/2, the whole thing squared, is equal to 0. And when you have that, now since it's equal to 0, I've got to set both of these equations equal to 0, but both of the equations are exactly the same, so I really only have to do it once. X minus 1/2 is equal to 0. I add 1/2 to each side, and that is my final answer. Okay, let's look at example 4. In example 4, before you get actually into example 4, they want you to recognize a simple thing about the square root property. The square root property is, let's say I have the square root of 49. Well, the square root of 49 is not just 7, it's plus or minus 7. Because negative 7 times negative 7 is also square root. So when you're doing a square root, both the negative and the positive both will work. And sometimes that comes into play. Let's say you have an example like 4a. We have the value a plus 4 squared is equal to 49. And we're asked to solve for a. Well, what we can do is we can take the square root of a plus 4 squared, and we square root both sides. Okay? This side, it's kind of easy to see that the square root takes away the square, so we're left with a plus 4 on this side. On this side, it's very tempting to write 7, but that's what we're trying to point out, is you write plus or minus 7. And since you're trying to solve this equation, now you have 2 equations to solve, one with plus 7 and one with minus 7. So write them both out. A plus 4 equals 7, and a plus 4 equals negative 7. And then when you subtract 4 from both sides, on both equations, okay, I'm solving them both at the same time, but it's 2 different equations. I'm left with a is equal to 3, and a is equal to negative 11. And then that becomes my solution set. What about 4b? 4b, we have y squared minus 4y plus 4 equals 25. And the first thing I recognize, instead of switching the 25 over, which is what I would normally have done and then tried to factor the whole thing, I realized right away that this is a perfect trinomial. So I can say y squared minus 2 times the square root of the first term, y, times the square root of the second term, 2. Notice that 2 times y equals 4y, plus 2 squared equal 25. So since this is a perfect trinomial, I can take the first value, y, the last value, 2, put the sign that's in front of the middle term, minus 2, square it, equals 25. And now you can kind of see how the square root's going to come into play here. I'm going to square root that whole thing. Square root on both sides of my equation. I then get y minus 2 on this side equals plus or minus 5 on this side. And just like the last example, I now have to write two equations. Y minus 2 equals the positive 5, and y minus 2 equals the negative 5. I add 2 to both sides here, I get 7. Add 2 to both sides here, I get negative 3. And my solution set is negative 3, 7. And finally, 4C. C is x minus 3 squared equals 5. And in this example, we're going to do one that shows you that it doesn't always come out so perfect. Okay? So, right away, I've got x. I want to get rid of the squared. I'm going to take the square root of both sides. X minus 3 squared, the square root of it, and the square root of 5. Okay? And when I do that, I get x minus 3 equals plus or minus the square root of 5. Because the square root of 5 doesn't really have a, doesn't have a perfect integer square root, so I've got to just say that it's plus or minus the square root of 5. And then now I have two equations where x minus 3 is equal to the positive square root of 5, and x minus 3 is equal to the negative square root of 5. And then add 3 to both sides. X equals 3 plus the square root of 5. And here I would add 3 to both sides. X equals 3 minus the square root of 5. And I could use my calculator to calculate that, or I could leave it in this terms, in these values, and my solution set would then be 3 minus the square root of 5, comma, 3 plus the square root of 5. And there is my answer.